Hello and welcome to a Level 3 Cambridge Technical Engineering revision session for Unit 3 Principles of Mechanical Engineering. We're going to look at two more videos. This is for question 6, which is kinematics, and the first part is to do with kinematic or dynamic calculations, and the second is to do with aspects of momentum and a little bit of beam theory. So 6a then is asking you about a ski jump, and it shows the profile view of a ski jump. We have a distance of 20 meters here, 12 meters here, 25 degrees here, and a and a B point, which will be relevant to some question. So part A then is to calculate the loss in, and here's a key thing, is potential energy of the skier between points A and B. So if we look at our dynamics, we have gravitational potential energy is the mass, gravitational acceleration and height, remembering that the exam criteria asks us to use 9.8 as our... Sorry, just stop the video there for a second. So we're using 9.8 as our figure for G, and then mass, gravitational acceleration and the height. So if we look here at our diagram, we can see that he starts off at the 20 meter point, comes down the slope, but finishes at 12 meters above the zero line. So the total distance, total height, is in fact 8 meters. So the energy, potential energy, will be basically mass, 80 kilograms, multiplied by acceleration due to gravity, 9.8 meters per second, multiplied by the height, in this case 8 meters. I've got 80 times 9.8 times 8 is 6272. 6272. And the figure we're looking for is joules. Given that the work done against resistance between points A and B is 2000 joules, so we're going to lose that somewhere along the line, calculate the speed of the skier at point B. So we're looking at speed. So if we're thinking about gravitational potential energy, as we lose potential energy from here, we gain kinetic energy. So we have potential energy here, and we're talking here about kinetic energy. And the reason that's important is because we're talking about speed, and the kinetic energy has velocity in it. Kinetic energy is half mv squared. Again, you'll find that in your dynamics section. So if we bring in the so we're looking at half mass times velocity squared, half mv squared. Okay. So, well, it's got 6,272 joules. We lost 2,000 due to resistance, so we're left with 427 joules. Now, kinetic energy and potential energy are effectively, as you lose one you gain the other, so they effectively can be the same. So 4272 joules is equal to half the mass times the velocity squared. So we can rearrange this to give us, so I can have, get rid of the half, so times that by 2 over 1, reciprocal, so we end up with 4272 times 2, and again multiplying by the mass, so we do the mass over 1, to divide. The mass is 80 kilograms, and it's a root, so we take that, square root that, and that will give us velocity. So, bring the calculator in. 4272 times 2 is equal to 8554. Divide that by 80, and then take the root of that answer. So the velocity is equal to 10.33 meters per second. Now, slide this up to look at the final part, part 3. It says the takeoff point for the jump is point B. That's I can't see that on the diagram here. I'll work that down for a second. Point B here, 25 degrees. It says where the slope is inclined at 25 degrees to the horizontal. Guess what? 25 degrees, it's an angle, it's probably going to involve trigonometry. Which is good. We like trigonometry. So, given that the skier is in the air for 1.8 seconds, so 25 degrees, that's important, 1.8 seconds, calculate the horizontal distance travelled during the jump. It says you may assume horizontal resistance is 0, so air resistance, etc., 0. Right, stick that down, let's have a look. Okay, so let's just think of this as a little diagram with horizontal. So we're going in 1 second, we travel 10.33 meters. Okay, we're doing that. 10.33 meters would be at an angle of 25 degrees. Okay, so in 1 second we'd have got that far. Well, that's 10.33. So if you think of that as being the hypotenuse, then this horizontal distance here would be shorter than the hypotenuse. Okay, and it would be shorter by the ratio of, well, that's an opposite and this is an adjacent, so this will be cosine. So the cosine of the 10.33 is going to give us this horizontal, but that's just for 1 second. So let's have a look at what that would be. So we'd have 10.33 meters per second multiplied by the cosine of 25 degrees, which would give us 9.335 meters per second. So in 1 second, that distance there would be 9.335. And if it went for 2 seconds, it would be another 9.335, but it doesn't. It goes for 1.8 seconds. So we end up with 9.335 multiplied by 1.8 seconds, which will give us our distance in meters of 16.9 meters. Okay, I hope you found that useful. The next video will be looking at 6b, and I hope you do well in the exam.